Hello, today we're going to be looking at what does the equal sign mean and some other relational concepts around the equal sign. Under secondary math resources, you'll find all of the documents. If you just keep scrolling down, it's going to be equality and the equal sign. And if you keep scrolling all the way down to the bottom of the math professional development, you'll have the concept of equality and number balance. And once it opens up, we're going to be talking about all of these things. If you look down on the bottom, you have the equal sign to explore. I'm going to make reference to that one a couple different times. The Equality Unit 1 lesson notebook, I'm going to be referencing that quite a bit. There's an article titled Equal Sign, and it has all those letters, JRMEK, from Knuth over at Madison University in Wisconsin. That he really outlines the whole work of the equal sign, and we're going to be referencing a lot of his. It's a great article to start with if you want to look at that. The next two, number balance objectives and number balance, are just two resources for you to use, possibly with kids. And they go the whole gamut of everything. And then the last one, the possible equation sequences, will make reference to some of those. But really, as you're kind of looking at for professional development purposes, you want the equal sign to explore, the equal sign from the Knuth, and then the possible equation sequences. And we'll be starting to talk about each one of those. Okay, so now we're in the Smartboard version of Equality Unit 1. And the whole concept of equality underlines every algebra topic mentioned in the Minnesota State Standards in grades 6 through 8. It's one of the main stumbling blocks that our special ed students have as they go into algebra classes, and it's one of those misunderstood concepts that the kids have that we need to correct, and we can really go a long way with those students once we fix those underlying misconceptions. Students begin by viewing the equal sign as a do something symbol or as an answer of what comes next. We need to move them through that thinking. This training today, we're going to talk about a couple different things: the sophisticated understanding of the equal sign, looking at different benchmarks needed to help children develop relational understanding of the equal sign, and then we're going to use some true and false type questions to help you start thinking about that. So we're going to go into the next slide. So the first question I always like to ask kids: students demonstrate inadequate understanding of the equal sign, and this is what we're going to kind of go over with all the questions here. So what is that symbol? 5 plus 3 equals 8. And a lot of kids will say it's an answer. What we're going for is it's a balance. That you do it to, if you do something to one side, you do it to the other. But we really want kids thinking, yes, it is an answer, but it's a balance on both sides. So what is the symbol? What is the symbol? What does it mean? And can it mean anything else? Are the typical questions that you want to ask kids as we're going through. On the right-hand side, you see 7 equals 7. And I like to do this, possible equations for sequencing. That's going to be the reference article that we were kind of talking about it, and it has a lot of these questions in there. So 7 equals 7. Would a kid say that's true or false? Now, hopefully they're going to say that's true. And then we look at some other questions. How about 5 plus 2 equals 7? Is that true or false? And we'll have some kids say, yes, that's true. But then you're going to start seeing some misconceptions happening when we start looking at problems backwards, where the equal sign is not the end all. So 7 equals 5 plus 2. Some of your kids are going to say, nope, that you can't have that. But then when we look at other questions, like 8 plus 6 equals 2 times 7, is that true? You're going to have a lot of kids say, nope, that's not true. And that's what we really want kids to start seeing, that it's a balance on both sides. And when we're doing things, we want to keep having it going back and forth. There are two different thinkings as we're going through. One is relational, which means the same as. And that's one of the thinkings that we want kids to get to. And in the Knuth article, it talks a lot about that. The next one is operational. We don't want kids to be operational all the time in questions. That's where we add the numbers, or it's just the answer. We want to go to that relational thinking. In the Knuth article, it talks about the one question, 8 plus 4. 8 plus 4 equals equals x plus 5, or usually it's a box there. And a lot of the misconceptions that kids have is they're going to answer that either with a 12 or a 17. And if they're doing that, they're really operational in their thinking, and they don't have that balanced thinking. So if kids are now having an answer of either 12 or 15, we know that they're operational, and it's something that we need to fix and work on with those students. Here are a couple examples of, okay, now how do we take this further? You have strategies. Here's a question: 4m plus 10 equals 70. So now you're looking at those questions. The first one is a guess and test strategy, where a student basically just kind of started thinking, okay, well, 20 times 4, that equals 100. So 15 times 4, that equals 60, trying to guess where do they start. And then they know 15 should be the value for m. So it's just a guess and test. It's a strategy, not very sophisticated, and it's not quite where we want kids to go, but it is a strategy. The next one, strategy that you see, is this unwind strategy is what we call it. And the student starts with a number, 70, they subtract the 10 and get what the answer is. A little bit more sophisticated. And then from there they do your division equation, go through, and then m equals 15. There's another version of that. Here, and you might not have seen this before, but it's kind of neat, but it's that unwind. You start with m, so you look at your equation, what is happening to m? M is being multiplied by 4, and then you're adding 10, and then the answer is 70. Then you unwind it. So answer 70, what is the inverse of adding, or my answer is 70. I need to, what's the opposite of add 10? Subtract 10, and then I get 60. So now my answer is 60 multiplied by 4. What's the inverse of multiplying by 4? Dividing by 4. So I'm going to divide 60 by 4, and then there's my answer. Both of those are unwind. Another strategy that you will see in the Knuth articles is what value of m will make the following number sentence true. And this is that algebraic thinking, where it's not just a rule, we want to know what is happening with those rules. So if you subtract 10 on both sides, why are we doing that? And then divide both. Both are just different strategies that we're doing. But really, when I'm looking at 4m plus 10 equals 70, I know that 4m has to equal 60 just by looking at it, because 60 plus 10 is 70. And do kids know how to solve problems that are like that? Then the last problem down here, we can really tell if they're operational or relational. You look at the different numbers. What is the difference? Well, there's a 9 on both sides. If I get rid of those, it's the same equation, so they're the same. There's another part of the article, or in the resources, called using the equal sign to explore the different problems, and it talks a lot about true-false statements and all the different strategies that we look at, like reflexive property, symmetry property, basic properties, and it's really getting into a lot of different concepts. Check it out. I think you'll really like some of the resources that are there. And just make sure in the article too, or in the Smartboard, there are 2 other versions of things that you can look at. All you need to do is pull them to the left, and you can see here is that missing number. This is that true or false, making sure you have, or making sure the kids know true or false, what is the thinking behind them. Then you get into filling in the missing number using different strategies. Here, 14 plus 6 equals 15 plus what? Well, it has to be 15, because 15 is one number lower than, or one number higher than 14. So it has to be 15, because 15 is one lower number than 16. That's that relational thinking. Down here you have this distributive property that this has to be a 4. And then going over here, relational thinking, 37 plus 56, is that equal to 39 plus 54? Well, 37 is 2 lower than 39, 56 is 2 higher, so that number is true. And as you keep going, look at the problems down here. What is making this equation true, what is not? Well, I know what is that answer of D. So those are some of those things that we want kids to start thinking about. The last part in the whole Smartboard version is this thing called hands-on equations. Hands-on equations, you do have an account somewhere in the building, and if you're interested in using it, you can. But on the whole hands-on equation, it starts off with an equation. 3x plus 6 equals 18. So you first going to start off with 3x, and the pawns are your x's. So I'm going to have 3x, and I have a 6. Greens are positive. So 3x, let's see, 3x plus 6, sorry. And over here, I'm going to put a 10 and an 8 for 18, which is it's kind of confusing for some kids. Some special ed kids really like it, some don't. So that's 18. You're going to subtract 6 from both sides, typically is what we would tell kids. So we're going to subtract 6, and I'm going to subtract 6 from this 8, which makes it a 2. Hang with me there for a second. My recording symbol's in the way. Okay, here we go. 2. So now it equals 12. So 3 times something equals 12. 3 times what? It would be 4. And then 3 times 4 is 12, and then it's equal. You can see a lot of different resources for hands-on equations, but there are other tools for you to use hands-on equations down there. And if you email me, I can help you with some more resources with that. But that is today's information on the equal sign in a real quick down and dirty.